Professor, your mic is muted.
Okay, can can uh, can everybody see my screen?
Yes.
Yeah, thank you. I'm sorry that for some reason I was trying to record it, it crashed right at that moment. Okay, so Manuel was asking for the different addresses. So I just want to use this. Number one, I'm going to use this. Number two, I'm going to show you something that I think Manuel asks two questions about. One question is about whether the pointer, are they supposed to be the same? Or the other thing is that what is the idea of a virtual table? So I'm going to first answer the first question about those pointers. I'm going to copy this to a different slide because it's going to be, I'm going to change this. I want to keep the original. Okay, so I'm going to use this one. So I assume everybody can see my slide. So let's look at multiple inheritance. I think is if your program get the following, I think you're doing it right. So the work study pointer, the employee pointer, the count object for the employee, this three pointer under multiple inheritance should be the same. So let me actually add another one here because what I see here is I would just use ACC, okay? So you know what I meant. And then I'm casting employee star. Let me do it. And then whatever WS here, okay? So if you, this three, work study, employee, account star, employee star, means that you casting to the employee first, then you casting this. This three should be the same, pointing at the beginning. Okay, by the way, this is a lower memory address. This is lower, which means that this three, while they're the same, the value of this three, which is one value, should be smaller than this value here. And this value actually include two pointer, which is student pointer and account student star WS. If you take this one, let me actually change the color to a different color. Let's use purple and go up. Okay, so if you see for multiple inheritance, if you see this result, then I think you're getting the right thing. This three should be the same. I mean, the reason why the three things has to be the same, because think about the compiler. Because if you're pointing here, the account E, of course, is it knows it's account, so the compiler know the memory setting for account. But for employee, because left first, so employee will actually, because it's a left on the inheritance. If you look at the original code, that the multiple inheritance, the left is employee, right is student. So left goes first. That's why the first one will be left. So the employee, because the compiler know employee inherit from accounting, so that's why you have accounting, you have an employee here. Employee also pointed here. And of course, if you're a work study, because you know the whole thing, that's why you know the memory layout. That's why you can also pointing at the beginning. Basically, if you pointing the beginning, I will be able to know which variable is where. That's what we want to do. But here, you cannot do the same for student, because the thing is that you don't know whether this is a original student or original account, or is actually a work study object, because the layout, because the pointer is casting. So that's why if you casting to the student or casting to the student's version of account, then you have to point in here. I mean, think about this. If I pointing account student work study and I didn't change and the pointer is still pointing here, then I'm actually accessing the wrong account. I'm actually accessing account E instead of account S. So that's why you have this two group of addresses. And similar idea to the left side, which is virtual inheritance. The virtual inheritance essentially is doing the same thing. Is that do you know where the variable where it is, so I can actually get access to that. And because of this structure, I no longer can do similar here. I mean, the reason you have a two account, I can do this is because you see account employee, they're putting together. Account student, they're putting together. I'm sorry, here you cannot, because where are you going to put this account? Are you going to put this account associated with employee or account associated with student? Because of the virtual inheritance, that nice property about how the object, that base object, derived object memory can be put together, that one is gone because you have two. So you no longer can do this. So therefore, to be accessible to all of this, you basically using a pointer, then employee. You use a pointer student. So instead of putting the yellow box here, I'm essentially putting a pointer, and the pointer is indirectly pointing here. I mean, theoretically, you can actually just make this pointer directly point here. It's just saying that, hey, this is a virtual inheritance. I'm sorry, don't do that. Just directly access to that. And that's not really realistically is happening in the implementation. The implementation looks like this. Let's see. So now I'm actually answering the virtual address. I think I talk about that in the next slide. Hold on 1 second. Where's my slide? Let me open the slide. This is the table I was talking about. So this is called virtual table. So what virtual table is, it has a bunch of pointer, and some of this is pointer for a function, but they also have a pointer to some of the object as well. So when you see that virtual table, that virtual inheritance class object looks like this, but then there is a member is going to pointing somewhere over here, and then it will have some pointer set up in the V table. It will point back to the area which I show you over here, like this. Like this one is pointing to the virtual table, and virtual table has an entry that point back to this account. Then you can actually, you see that, okay, now that you have 3 sessions. If you're an account object, then you're pointing directly at here. But if you're either employee or student, you have 2 different virtual table. And then they will point out for the account, but then your individual object is here, employee and student. And work study, you're actually doing it here. Okay, so that's kind of the setting for the virtual inheritance. So in other words, in virtual inheritance, the compiler will know that this is actually being virtually inherited. So therefore, because of the virtually inherited, so I know to interpret this not as the account object, but as this as a virtual pointer. Okay. So is that helpful for you to understand the difference between multiple inheritance, the virtual inheritance, the virtual table? Manuel and anybody else?
Yeah, can I just verify like one thing for an example?
Sure. Mm-hmm.
So we have at the bottom of the virtual inheritance like diagram, we have work study, and then say in the top of my code to start off with, I made a work study object, and then I made a pointer to that work study object, and then to get employee like in the green for the virtual inheritance, to get that address, could I just do the object of the work study pointer and then just cast it with employee star. Like, does that make any sense?
Yeah.
What I
So
just said?
the way to do it is it should be similar to this way. Let me see. It should be similar to this way. Let me actually just write down here. Assuming this work study is a virtual inheritance. Okay. So if I understand you correctly, is if you want to go to employee, just say employee star, and then end obj ws,
Yeah,
just like this.
yeah.
This will get you to the employee star, which is here.
Okay. And then okay. So would that be the same thing as like the because that employee in the green is the same thing as the V table pointer right on top of employee, like the gray
That's
one?
right. That's right. So employee star WSDR, they should be pointing to the same thing here. So here you have 4-pointer, right? 4-pointer point to the account, employee, student, and the work study. The work study and employee should pointing at the first byte here.
Okay.
And then the student pointing at here, but the account pointing here. See, the thing is that you cannot directly put employee pointing here. In fact, it's very interesting. Employee object in neither case pointing directly at the employee. In this case, it's pointing to account. In this case, it's pointing to the virtual pointer. It's never pointing at the employee or student. If you think about that, there's a good reason for doing that. Because the employee really have the account. The account is really part of the employee. So in this case, this account is only belong to this employee, but this account is being shared by two object, which is employee and student. That's why you need to do that.
Okay. Yeah. I just wanted to clarify that. That's good. Thank you.
Hi, Professor. Could I ask some questions about the first part of the part 2 of homework 4, such as the address for the components?
Sure, go ahead.
The result should be different, right?
The runtime result. The runtime result means that the execution time of copy IJ should be much faster or smaller in time than the copy JI. Right? That's a question you're asking, right?
Oh, I mean for the part 2 of the homework 4.
Oh, part 2. Sorry, I thought you said part 1. Okay, go ahead. Go ahead.
You have already said that the address value of object pointers under the influence of casting, and a little bit wondering about the address for the class components.
Okay, that means, for example, W1 or S1, those kind of thing, right?
Yeah, I got I got 4 or 5 different results for them in my program. Is that right?
Yeah, that I think it's right. If you're looking at the multiple inheritance, this is the memory layout, right? So you're supposed to get 5 different results. Because over here, account E, you have A1. Employee, you have E1. Account S, you have another A1. And the student have S1, work study have a W1. So you have 5 variables. They are actually distributed in this 5 different addresses. I do want to challenge you to check though. See, I actually put it here saying that this is a lower address, right? Let me just make sure I get it nicely done here. I'm sorry, try to be more. So the address really go this way. Okay, let me actually just put the red thing here. Okay, the addresses really go here. So for example, multiple inheritance, you're going to see 5 addresses. And you will see that those 5 address that belong to 5 address mean 5 variable. Okay, A1, E1, A1, S1, W1. You should see their address are exactly distanced by each other by 8, because each of the variable is 8 byte. There's no other variable. So you will see that this one is the lowest one, plus A, you will get next pointer, plus A, you'll the next pointer, plus A, plus A. If you see your 5, and you're getting that correct spacing, then you know you're getting the right result. So similar here, you can do the same thing, but it's a little bit tricky is that over here, this is also the lowest. But you will see that the address for the work study object pointer, you plus 8, you're going to see the E1, the address of E1. And then you're going to plus 16 to see the S1. And then plus another 8, you're going to see W1. And then you plus another 8, you're going to see A1. Okay, so it's not only you're going to get like in virtual inheritance, you're going to get 4 different memory address, but also their spacing are interesting. Each of the block I draw here is represent 8 bytes based on the program I gave you, because every class has only 1 variable and that variable has 8 bytes. So that's why its spacing was 8 bytes. So this is actually interesting because it's the whole design of the homework is really just for you to have a firsthand experience about the memory layout difference between virtual and multiple inheritance. You can see that in the multiple inheritance, in the memory address is always account come first, and then you come to the employee and then work study. It goes like this way. So the base class has a lower address than the derived class. But virtual inheritance is exactly opposite. If you see that this is, in fact, the base class, which is account, has a highest address here. And that's I want you to validate, to use your program to see that result. So just clarify, we have 2 sets of pointer you need to investigate. One is pointing to the object. Pointing to the object that you actually have 2 different addresses in multiple inheritance and 3 different addresses in virtual inheritance. That's pointer to the objects. But in terms of pointing to the member, which is A1W, S1, E1, then you're going to have a 5 different pointer in multiple inheritance. You're going to have a 4 different address in, I didn't ask you to print the virtual table address. I mean, you can do that, by the way, but I'm not asking you to do that. But you're going to see 4 different pointer. So that's the first part. You see the difference. And then I want you to see the value as well, and to see if the value really adding according to this diagram and this diagram from the lowest to the highest.
Okay, I get it. Thank you.
You're welcome. Check. Okay, I'm going to stop recording for a while. Hold on 1 second.